Today we're going to talk about why safe organizations fail. First of all, Gordon mentioned his beloved Rough Riders. I too am a beloved Rough Rider fan, as probably many of you are here in the room. But it begged a question. I'm assuming there's probably a few people in the room who do like some of the other teams. And I have a soft spot for a few of the other teams as well. But just a quick question. Anybody in here a Bombers fan? Any Bombers fan? Come on, any Bombers fans in the crowd? Yeah, we got one back there. We got a few. That's good. Excellent. Well, welcome to the Institute. And I'll come back to that in a little bit. There's an important reason why I was looking for some hands there. So thank you very much for that. So why organizations fail? We're going to talk about a few things today. I hope it's a bit entertaining. I will apologize to the fellow who's trying to follow me around with the camera. I do like to wander. I do like to chat. We're going to have some interaction, hopefully a few laughs. But more importantly, we're going to provoke some thought. What we have found with SafeMap International over the years is that there are some common themes behind why some of the safest organizations in the world have challenges. The same challenges that you and I have had in the past in organizations either we're currently working for or have worked for in the past. So SafeMap has been around for a while. Corey Pitzer is our CEO. He's done extensive research around the world looking at lots of different disasters. On the board here, just a few of the more well-known disasters that we've had the ability to research. We found some common themes in those. Does anybody know who Captain E.J. Smith is? Captain of the Titanic. So Titanic, April 15th, 1912, very well-known disaster in the world. Lots of us profess to be experts in the Titanic. Lots of us are. Probably a lot of you know way more than I do about the Titanic. Very interesting information about the Titanic and what caused it. Lots of theories. Lots of things that are unknown. Things that didn't show up in the movie, basically. So the Titanic set sail, was leaving the Queenstown Harbor, and what a lot of people don't know is that there was a delay of about an hour and a half the morning it was supposed to set sail. There was another ship had broken away from its moorings, and due to that, the Titanic was delayed, and it had to sit in the harbor for an extra hour and a half before it could leave. So as it set sail from Queenstown to New York, this was its maiden voyage. Captain E.J. Smith was at the helm. And we've heard lots of information about this. We've watched the movie. There's lots of detail around the Titanic and what caused the terrible event that day. But has anybody ever told you the story of the iceberg? There was no movie about the iceberg. It barely got a cameo in the movie. But it had a story too, and it had a very important story. It broke away from Iceland probably hundreds of years earlier, prior to this event. It was just on its own way, minding its own business. And on that fateful day, it happened to be in the exact same spot as the Titanic as it was barreling through the ice fields that day. The Titanic happened to hit the iceberg, and as I mentioned earlier, had it not been delayed in Queenstown by that hour and a half, they predict that it likely would have missed the iceberg by 3/4 of a mile. That would have been a safe event. Would have been a non-event, right? Wouldn't have happened. Titanic likely would have made it through to New York safely. We wouldn't have a movie. James Cameron would probably be a few $100 million slighter in his bank account, and we would have never have heard of a two-bit actor by the name of Leonardo DiCaprio. But it happened. Shortly after the Titanic struck the iceberg, there were mayday calls that were sounded, and even back then, without social media, the media got hold of this right away. And they, in New York, questioned the owner, the managing director of the White Star Line Shipping Company, the owner of the Titanic. And at that point in time, he said, "We believe our ship is safe. It is unsinkable." And that was the same mantra that the engineers and Captain E.J. Smith had as well. It's unsinkable. It's quite probable, if you look at the timing around that statement, the Titanic was likely already at the bottom of the ocean when he released that statement. Now, in our journey of exploring all the other catastrophic events, we've found similar Titanic organizations. Organizations that had similar themes and issues that may have resulted in the Titanic. Has anybody heard of the Bhopal, India event? It's a pretty huge event in the safety world. Does anybody remember who the organization was? Union Carbide? Does anybody know where Union Carbide is today? They are an affiliate of Dow Chemical. They were basically taken over by Dow Chemical. Back in '84, 3,800 deaths attributed to a leak from a valve, which leaked water, simply water. However, water leaked through into a methyl isocyanate tank. Chemical reaction took place, and the toxic cloud from that killed thousands of people. And some people are suggesting maybe hundreds of thousands of people had impact from that one event. Piper Alpha, September 6th, '88, oil rig in the North Sea off Scotland, 167 killed. Does anybody know who the owner of the Piper Alpha was? Occidental Petroleum. Texas City Refinery, BP, one of the safest companies in the world, as was Occidental, as was Union Carbide at the time. They were highly regarded by their peers and by industry as being the safety leaders in the world, especially in industry. However, even at BP, March 23rd, they had some fatalities. 15 killed, 170 injured. They were benchmarked by their peers to see what they're doing that is different. Deepwater Horizon, 2010, 11 killed. This team received a safety award that very day from their executive. This is Transocean. Transocean was well known for their safety practices and their performance, great performance. So much so that BP, who actually owned the rig, they hired Transocean to do the drilling. Great companies, very good companies. DuPont, the pinnacle of safety industries, DuPont. They've even developed systems and programs which probably most of us, if we're not using right now, have used in the past. Very good company, well managed. They too had some fatalities back in 2015. Does anybody know this ship? Costa Concordia. So the Costa Concordia, fairly recently, Captain Charito was not paying very close attention and ended up running into some rocks a little bit closer to shore than probably should have been. There's lots of theories behind what happened. There's very interesting stories if you want to Google that, but resulted in 32 fatalities. That's just a little bit of a comparison between the Titanic and today's cruise liners. Puts into perspective. Today, we have lots of technology, lots of innovation that helps us to control risk that they didn't have in the days of Titanic, which enables us to be larger, more productive, safer. So in our exploration of those incidents, we found that the common trend behind all of these were that these organizations focus strongly on safety as a core value. Their safety approach was on technology, systems, audits, and enforcement. They were fixated on compliance behavior and the elimination of at-risk behavior. Leaders were highly committed to achieve best-in-class safety performance, and they targeted and achieved low accident rates. That doesn't sound so bad. Does it sound like any of the organizations you guys work for right now? Probably, because they're all well-managed companies. These are all well-managed, best-in-class companies. If we look at USA incident rates, we've done well. We've done really well. Since 1993, the non-fatal injury statistics show that we've decreased the statistics by 64%. And about 2009, something changes. Beyond 2009, we have a reduction of only 16%. Seems to line up really well with the Bradley curve for any of you that follow the Bradley curve. However, what we aren't seeing is the systems and technology and products that we use to manage non-fatal incidents isn't having the same impact on significant incidents or fatal incidents. We've only seen a 32% increase over that same amount of time. And since 2009, as well, only 2%. And for the first time in history where we're at our safest, we are at our safest, and for the first time, we have actually seen our fatal rate start to creep up again. So we at SafeMap think we've hit a wall. For some reason, back in 2009, something's changed. We hit a wall. And we don't know what is lying on the other side. We're not sure how we're going to break through that wall. We have some ideas. We're going to talk about them here today. In order to talk about those, we need to understand what got us to the wall. And we've talked about a few things here today already which have done that for us and have done that well. They've served us well and are still serving us well. We analyze, prevent accidents. We engineer safe work environments. We enforce safety rules. We educate in safe work procedures. We set accountabilities for safety. We eliminate at-risk behaviors. We set safety targets, and we reward achievement. These are all great things to do. They've done really well. Look, 64% reduction. That is impressive. But we think we've hit the wall. We've hit something. Something's changed in 2009-ish. So how do we break through? As a group, as a set of leaders here today, how do we break through to what's waiting for us on the other side of this wall? All right, so I need to tell you a little story about Grant Davis. Now, Grant Davis was a young fella, grew up in South Africa. Our company is rooted in South Africa. SafeMap International got its beginnings with Corey Pitzer, who is a South African. And Grant Davis grew up there, about 8 years of age. His family moved back to England. They moved to Leeds, but he always desired to be back in South Africa. He loved it there. He loved the environment, the animals, he had friends, and he always longed to return to South Africa. So Grant Davis went to university in England, got an electrical engineering degree, and decided after he got his degree he was going to take a gap year. And during that gap year, he wanted to get back to South Africa, back to what he longed for. So he applied for a few roles, ended up getting a job as a park warden in one of the national parks in South Africa. And it was like his dream job. He couldn't have handpicked it any better. One of the things that Grant does, and he really looks forward to every week, is he organizes the safaris. So has anybody been on an African safari? Anyone? Few? Yeah? So it's an amazing experience. I have not. But for those that have been on these safaris, it's an amazing experience. It was what Grant looked forward to the most out of his week. And he always had fantastic luck at a certain watering hole. At this watering hole, he was able to have a really wide variety of animals. The odd attack even happened while their group was there. So it's a bit unsafe, so they were always protected in their safari vans. They had to have a gun on hand just to ensure their safety. And this one specific day, Grant was with the group, and he heard something abnormal. So what Grant heard was an animal in distress. It wasn't a typical elephant trumpeting that he had heard in the past. There was something wrong. He knew something was wrong. And so out of care, he decided he wanted to go and check it out. So he asked everyone to stay back at the safari group, and he took his gun and walked in behind the watering hole and behind a wooded area, and he seen this young bull elephant. And it had been snared in some wire that had been wrapped around its leg, and you could tell that the leg was definitely in need of attention. And typically what happens is, most of you might know, poachers in South Africa, they'll snare elephants, they'll cut off their tusks, sometimes leave them for dead or shoot them or do whatever, but it's a drastic consequence, right, of those types of trade. However, Grant looked at this poor animal and thought, it's probably not going to make it. It's got a really bad foot. So he decided to take his gun and end its misery. So as Grant is holding his gun to the elephant, the little elephant opened up its eyes. And if you've ever seen an elephant up close, they have these big, beautiful black eyes. And he kind of looked at him pleading for his life. And Grant felt sorry for him. And as he was still sitting there waiting, the elephant had raised its snout and started to smell Grant's hand. And Grant just couldn't do it. He couldn't pull the trigger. He just couldn't do it. So he pulled out his Leatherman, happened to have Leatherman in his pack, and he cut the wire away, and he thought, geez, if maybe I can just help this poor elephant back up. And if he gets up, maybe he'll survive. So he cut the wire, moved it away, and tried to push it, tried to get its attention, tried to move, and the elephant just couldn't move. So he grabbed onto its trunk, and he pulled with all his might, and finally, for some reason, the elephant found enough energy to roll itself up onto its feet. And it stood up, and it looked at Grant with these intense eyes, and it trumpeted, and then it walked off very slowly, obviously with a sore foot, into the bush. Now, Grant obviously got back to the safari, told the story. When he got back to camp, he reported it to the authorities, but to no avail. You never know. They couldn't find the animal because hundreds of elephants get killed every week in South Africa still. So they wasn't sure what happened to it. So Grant, anyways, a couple weeks later, he met a fine lady from Chicago, Marlene. Marlene is a physiotherapist working out of Chicago. Grant falls in love. Packs up, moves to Chicago, they get married. Short while later, they have Grant Jr. Little Grant comes along, turns about 5 years of age, and Grant wants to take little Grant to the zoo, wants to see the animals. So they go to the Lincoln Park Zoo, and they spent the day there, a wonderful day. And on their way out, they're walking past the elephant den. And as they're walking past, Grant's pointing out to Grant Jr., showing him what he would need to know about the elephant, all the important things. And all of a sudden, the elephant turns and looks at Grant, intensely in his eye. He starts banging his foot on the ground. And he trumpets, and he starts to come right up towards the fence. Comes right up towards the fence where Grant and little Grant are standing. Grant's thinking, it can't be. It can't be. It's been so long. So Grant asks little Grant to stay back, walks up to the elephant, and the elephant reaches down with his snout, and he starts to smell. And he reaches and he grabs around Grant's waist, and he picks him up, and he smashes him on the rocks and kills him. It was the wrong elephant. All right, I see some shocked faces in the crowd. That's good. We will come back to this story because this is a very important story. Very, very important. One of the more important stories you might hear on safety out of my speech specifically today, maybe this next couple of days. All right. So what we found through our studies is that these organizations are doing a lot of good things, very great things. And they actually have dropped the statistics and saved a lot of lives over that period of time that we've seen on that previous graph. One of the things that we'd like to talk about is the Swiss cheese model. Now, this is one of the sacred things we talk about in safety. I've been a safety professional for 24 years, and it's one of the sacred things, and it is absolutely value-adding. However, we want to make sure that if this is one of the things that's helping us not break through the wall, that we challenge it, that we think more deeply about it. So with the Swiss cheese model, based on the Heinrich domino model as well, we look at things as being simple. Social environments and inherited, basically if you stop the dominoes, the event doesn't occur. It's that simple, right? So most of the time we look at mistakes of people as some of those dominoes. They're precursors to the accidents. And a lot of times the things that happen after the accidents are injuries or near misses or significant potential injuries. So is it as simple as just stopping the chain of events? All right, we're gonna have a bit of an interaction. Accident waiting to happen, I need your help. We've got a situation where we have a set of tanks, the blue tank, the number 2 tank in the middle. It goes through annual maintenance. It usually has a very corrosive material that's stored in it. So every year we need to take that tank offline and reline it. To do that, we also don't want to slow down production. So there's a way that we can do this constructively and productively and still maintain the safety for everybody involved. We need to actually draw down the product in number 2 and put some of that volume into tanks 3 and 4 and tank 1. The problem with tank 1 is that if you get out of ratio with the 2 chemicals in that tank, it becomes extremely explosive. All right? So to ensure that doesn't happen, we've got 8 controllers. We've got people who are analyzing the information at all times to make sure that we don't get that ratio out of spec. All right, I'm going to need your help here. This is simple math, and most of us in this room will likely blow this place up. There's 12 people preparing for work right outside of this tank. You will kill them if we blow this tank up. But it will likely happen. What I need you to do, simple math. It's just simple math. You don't have to write anything down. Just as I put a number up on the screen, I want you to say it out. I'll put another number up on the screen, and you add it. And I want you to do this loud so I know who blows them up. Okay? Be loud. I'm also going to give you an alarm. If you hear that, that means there's another number coming that's related to the flow going to tank 1. Is everybody ready? All right, we're ready? All right. 1,000. Oh, come on, I got to hear you. 1,000, excellent, good. Plus 40. Plus 1,000. Plus 30. Plus 1,000. Plus 20. Plus 1,000. Plus 10. I heard a lot of 5,000s. You blew them up. I asked you nicely. We gave you people to help. You were focused. I told you it was going to happen. And we still blew them up. There's the math. 4,100. So when incidents like this happen, we do something called incident investigation. One of the more common types is the 5 whys. So if we were to do a 5 why on this incident, first why. Why did it happen? Explosive mixture in tank 1. Why? Because the critical level was exceeded. Why? Because there was too much inflow from tank 2. Why? The control failed. And why? Human error. We all made a human error. This same set of circumstances were similar to the scenario at Chernobyl. Does anybody remember Chernobyl? A lot of younger faces in the crowd, so maybe not, but I certainly remember Chernobyl. During a testing event, they had bypassed some of the safeties, and a similar set of circumstances led to the impact of Chernobyl. Safety is not rocket science. It's far more complicated than that. Simple causation definitely has a place. However, what we would suggest is there's a randomness related to a lot of incidents that typically we don't see till after the event has occurred. Is anybody been part of an investigation that when you get down to the root causes of the investigation, you think, yeah, I guess we should have seen that, or I never thought that would have happened here, right? Hindsight's 20/20. However, lots of times there's so much randomness in these events, like Chernobyl, that's hard to predict. It's hard to quantify. It's hard to find that one domino or to plug the one hole in the Swiss cheese model. Since then, the Swiss cheese model has been mostly debunked by experts in our industry. However, it's one of the reasons we've seen such a good, drastic improvement in our incident rates. It absolutely has helped get us here. So the myth of simple causation. The risk matrix. Does anyone have a risk matrix? It's one of the cornerstones of the safety profession. So typically you have something like consequence on one of the axes of the matrix, and you'll have probability or likelihood on the other axes. And it's a really good way of quantifying simple risk. And it really helps us to understand where we should provide some focus. However, one of the challenges with it is the probability or likelihood. So a little exercise. What are the chances of you personally dying in the next 12 months? All right, I'm going to ask for your hands when I get to a number that you seem to think is the probability for yourself. All right, 1 in 10 years chance. Any hands? 1 in 1,000-year chance. Remember, this is dying in the next 12 months. 1 in a million. 1 in 365. 50-50. Right? It's tough. It's tough. The criteria we use for choosing likelihood is somewhat ambiguous. And there's some gray in there. And it makes it really tough for us to quantify risk matrices. And then we'll hand a risk matrix to the safety group. And our safety team will think, that first one wasn't fancy enough. We need to add some different colors and a little bit of flair. And then we get some engineers involved through engineering and design. And we add some formulas. Make it a lot more useful. Excuse me. And then we hand these risk matrices to our workers and say, do a pre-job risk work assessment and don't take any unnecessary risk. Do you think that might be difficult for them? I found it when I was a young fellow growing up in industry. I had no idea, right? But these serve a great purpose. Risk matrices do serve a great purpose. One of the problems with risk, however, is the theory of risk migration. I call it the whack-a-mole of risk. You hammer one down, you think you have it controlled, and it pops up somewhere else. Here's an example. They thought they had it controlled. All right, here's another example. So we have the privilege of working with a lot of mining companies, and most of my career has been spent in mining. And we were in Queensland, Australia, and we had a situation where a fatality occurred in one of the open pit mines in Queensland, coal. And the issue was that the spray truck, and if any of you have been in an open pit mine, you know that there's lots of dust in the summertime, especially in Queensland. It gets really dry there. And so it creates a lot of dust, and it's really hard to see. Not to mention there's some industrial hygiene risk associated with that, so they try to control the dust as much as possible. So these spray trucks are always go up and down the ramp. The problem is if you get stuck behind one of these trucks, they call it utes in Australia, but here they're Toyota Land Cruisers or whatever, F-150s, or whatever you have in the open pits. If you get stuck behind one of these, you have to wait. Lots of mining companies have protocols in place for how you overtake, how you pass. And in this case, you had to radio the operator of the spray truck, and he or she would then shut off the spray bar and pull over to the left. And they would communicate back to you that it was safe to pass. They were really accountable to make sure that nobody else was coming before they gave you that okay. So this day, the operators of the ute gave a radio call to the operator of the spray truck, and they heard a little bit of a chatter on the radio come back. I'm not sure if anybody has been working on radios. You know that sometimes a signal is just a quick little blimp on the radio. They heard that, and the spray bar shut down at the same time. Excellent. Okay, they've got the message, pulls over and stops. What they didn't know is that the operator of the spray truck actually didn't get that communication. Had no idea that this ute was behind them. He was pulling over and shutting off the sprayer because they also have a policy that if a haul truck is coming down the ramp, that they have to shut off their spray bar and stop. So the people in the ute figured that was their signal to pass, and actually the operator of the spray truck didn't even know they were there. He shuts down, the truck goes to overtake, and hits the oncoming vehicle. Now this is just an example. We didn't want to share the actual picture, but the operator died in that event. So what do you guys think? What rule could we set to ensure this never happens again? Any ideas? Yeah, confirmation radio. They thought they had it. What's another one? That's a good one, though. Yeah, certainly. What they decided to do was to set a rule that you can't overtake. No passing. Zero passing. And this caught on with other mines that were sistering to this mine, and they all put in policies that no more passing behind the spray trucks. No more passing on the ramps, period. Queensland set a regulation so all mines would have the same policy around overtaking on ramps. But what they found is that after a 10-year study, that there were a higher number of incidents resulting at the intersections at the top of the open pit. Now, if anyone who's ever worked on an open pit, there's always that one main intersection that's really busy at the top of the pit, where lots of things are coming and going. Why do you think that is? Why do you think there's more incidents occurring at the intersections? Yeah, because people don't want to get stuck behind the spray truck, because it takes them a long time to get up and down these ramps if they're stuck behind, and they can't overtake. So now they're racing through the intersections to get ahead of the spray trucks, resulting in more cross-on incidents, right? So another example of risk migration. So sometimes risk matrices, the work we do in risk, it's for the right reasons, but it can cause an illusion that we have everything under control. So we just want to be aware of that. Are we getting to the point where we're alluded to thinking we're totally under control? Behavioral-based safety, another sacred system, and it's provided a lot of great value for us. The problem with behavioral-based safety is sometimes in certain organizations, we can paint our employees all with one brush, and we think they're like this. Notice he's wearing a safety vest. Here it is in slow motion. Now the problem isn't that we paint everyone with the same brush. The problem is that that gentleman goes home, finds a lovely lady, settles down, has 12 kids, and they come work for you. That's part of the problem. All right. We tend to get labels with behavioral-based safety. We tell people that they were distracted, or they're rushing, or maybe they're fatigued, complacent, careless. They have the wrong attitude. or maybe they were working out of frustration. But I'd submit that it's a human's ability to be complacent to risk which gives us our productivity. If we weren't able to assume any risk whatsoever, we would never leave our bed in the morning. Right? You wake up, you get up in the morning, you got maybe slippery floor on the way to the bathroom, right? That's risk. You look over, there's my wife, that's a big risk. Don't want to wake her up, it's early. Right? You go to the kitchen. What are the risks in the kitchen? There's sharp objects everywhere, right? You'd never get in your car. Look at all the risks associated with just getting here today, right? If you weren't able to be complacent to some risk and assume some risk, you would never leave your house. That's what makes humans actually stronger. We'll talk about that in a little bit. Some of the other labels are inattention, incompetent, erratic, biased, violating, lapsing, forgetful, unreliable, inconsistent, and rigid. We've all heard these. Anyone who's done an investigation that centers on behavioral-based safety, sometimes we get to one of these. Human error. Well, why? Oh, they were confused. Or, well, we maybe need to retrain. Or they were incompetent. Tell me what you see here in this picture. Can't hear you. Coffee cup. What else do you see? Spoon. Why'd you say spoon? Yeah, it's a logical decision, right? We have certain things in our minds that as humans, we process things a certain way. The psychology behind it is that it was a logical assumption that that was a spoon. A similar assumption led to the Piper Alpha fatalities, 167 people. The Piper Alpha in the North Sea was connected to other operating rigs. It was the largest, however, and it was kind of the central point of transition for all of the product from these rigs. So they would pump to the Piper Alpha, and the Piper Alpha would pump to land for further processing. The other rigs, when questioned as to why they continued to pump oil and product to the Piper Alpha, which occurred, they continued to pump and transition oil to the Piper Alpha after they seen the flames and after the Mayday distress calls. And when they were asked why they continued to do that, they said, we assumed they'd get it under control. You see, these rigs have tremendous fire deluge systems. And they've never had an issue in the past. It was a logical assumption that they would get it under control because of the size of the deluge system and the fact that they've never had an incident in the past. Unfortunately, this day, there had divers in the water around Piper Alpha. And there was a decision made earlier because of a risk associated with having a diver drawn into the intake of the deluge system, because it's huge. If you're working around that system and the fire pump goes off automatically, you could get sucked into the intake. So they had it set to manual that day. And as a matter of fact, they had it set to manual probably about 30 to 40% of the time they were operating, because they always had divers in the water when the water was warm enough. So they had one of their critical controls set in a bypass state, and nobody realized that when the fire started. So why do people take risk? We talked about a lot of it is logical, and the fact that we're humans. We talk about human error. I'd submit it's not human error. It's the fact that we're human. It's human nature, right? Sometimes they're overlooked, they're underestimated, they're rewarded, they're inherent, they're balanced, or they're tolerated. We'll talk about each of these in a little bit more detail. All right. So where's the hazards here? That fella, he's a handler. The fella on the right, he's a handler. That's a Texas rat snake, right? They bite. They're a bit hazardous. The host is holding he thinks he's probably at the less hazardous end of the stick there, I think.
Texas rat snakes are going to be one of the largest snakes that you find in the Metroplex area.
Anyone see that? The little gecko over on the left-hand side? Right, who would have known that was the risk? I certainly wouldn't have. Play that again for those that didn't see it. So watch the bottom left-hand corner.
Texas rat snakes are going to be one of the largest snakes that you find in the Metroplex area.
So we see that that's an overlooked risk. Focused on one risk, didn't see the other. All right, sometimes risk is underestimated.
Dangerous part of the act.
And the doors are open! And the head is in!
Underestimated. Has anybody seen that clip before? Do you know what caused it? Yeah, a drip of sweat, right? Drip of sweat from the fellow's forehead. I'd been sweating, definitely. But he underestimated the risk, right? And he still does this. He still does this. That's his show. Guarantee you he wipes his forehead before he does it next time, right? Because now he doesn't underestimate the risk. Sometimes you underestimate the risk till you know that you should overestimate it. So reward and penalize. That fella had a reason to go through there. Whether it was going to the lunchroom, maybe it was the end of shift, it was going to the dry. He's definitely going to have to change his clothes now, right? But there was a reason for him to go through there. But we'd also say that there was an inherent risk there in the design of that walkway. There was no other way for people to get from that workplace to wherever he was going without passing through there. So what do? If we apply the hierarchy of controls, which we'll discuss in a little bit, we try to engineer that out. And like any good engineer, I've got an engineering background, any good engineer will add 2. Nobody can get through that. That fella went home, changed his drawers, came back and got a shoe shortly after. And we see this quite often in industry. Lifting. This is a recent one that we had from one of our visits to a site. And you have a person with their hand on a suspended load, right? And that makes up the largest portion of why people take risks. We tolerate it. We're willing to accept it. And sometimes that's our human capacity, and sometimes maybe we're tolerating it too much. So if you look at the 6 whys that we just chatted about, you can see that toleration and underestimation make for well over 50% of why people take risk. It's interesting. All right, we have a dilemma. Daryl owns All Carpet Company. He's been having some problems lately, though. New company's moved into town. It's a small company, so on the supply and demand cycle, he's definitely been hurting since this new company came in. However, he's gotten a call. There's Daryl. He's gotten a call from the mayor. Now, the mayor, she needs new carpet installed in her basement for her daughter's birthday on Saturday. So this new carpet's got to be installed, and she says, Daryl, I can't get the other company to come and do it. They're too busy. Can you come and do this? It's got to be done by 5 p.m. Saturday. And Daryl's like, yeah, absolutely. He said, this is the mayor. If I get this job, I'm set. Word of mouth is going to go so well, so it's going to run so rampant across the community that I'm definitely going to be saving. He's got 4 kids. He's got to feed them. It'll save his company. So Daryl shows up to do the job. So I need your help. Daryl needs your help. Help save Daryl. What does Daryl do? Squishes it. What else can he do? Remember, if he has to pull up that carpet to remove it, That's going to cost him hours. He's going to miss the 5 p.m. deadline. You know, it's not going to sit well with the mayor. She's going to be a little irritated, right? So one of the only things he probably can do is, we heard, stomp it. So what does Daryl do?
This looks great. This must be yours. I found it on the kitchen table.
Thanks.
Mommy, have you seen my hamster?
Well, isn't he asleep in his cage?
Have you seen my hamster then?
No?
But honey, go upstairs and look thoroughly. I'm sure. Probably behind the bed like where you found him last time.
Okay.
All right. Most of you have probably seen that in the past, but typically productivity is important until you see blood. All right, we see humans as probably the weakest link in a lot of our conversations, but at SafeMap we would submit we see humans as our strongest link. Humans, only humans, can be enduring, can be compassionate, imaginative, sacrificing, inventive, inspirational. Right? Artificial intelligence doesn't do this sort of thing for us. Standard operating procedure, or compliance to the standard operating procedure. Oh, sorry. So for anybody that is got a weak stomach, this is actually fabricated. This is not a real scenario. So if you watch this is people helping us understand what happens at different speed limits to pedestrians. Now, if we speed that up to 20 by 20 kilometers an hour, sorry, 20 miles an hour. Just seeing if you guys are sharp this morning. It's early yet. All right, in traffic science, we have a quadrant graph here. We have different types of behaviors, people who take risks on the right, acting safely on the left, comply with rules to the top, and break rules on the bottom. And they have this area here in the top left-hand corner, which is called the 85th percentile. This is where people typically operate, right? They call it the 85th percentile because this is typically where most of the incidents occur. Keep in mind this is a natural statistic. It's because most people operate safely and most people comply with the rules. It's a natural statistic, right? But 85% of the incidents occur there. Piper Alpha, of the 167 people that died that day, 109 people died in the accommodation block. The policy on the Piper Alpha was to go to the accommodation block if there's a fire. The helicopters land on helideck, they'll get rescued, and away they go. That day, that wasn't the case. There was a person actually who was a helicopter pilot who was working in a different trade that day, and he recognized through his risk competence that there was no way there was a helicopter going to be able to land in that smoke. And as a result, 109 people went to the accommodation block and didn't make it off the Piper Alpha. His brother, the helicopter pilot stopped his brother and pleaded with him to come with him, and his brother said, no, we must comply with the requirements, we must go to the accommodation block. 10 people survived who followed him that day, jumped into the North Sea, and survived. Bo Bobko says, the quickest way to get you killed in a manned spaceflight is to not follow standard operating procedure. Second quickest way is to always follow standard operating procedure. Standard operating procedures are awesome. They're awesome. And if our training is set up on good standard operating procedures, that is great too. However, if we see something, that's really good if they are always perfect. But if we see ways to continuously improve them, we have to be empowered to put our hands up and say, there's an issue here, and fix it and continuously improve. All right, hierarchy of control. So we talked about that real quickly. Swedish switchover. Does anybody know the Swedish switchover? Happened back in '67. So this was midnight on September 3rd. They took down all traffic in Sweden, and they were switching from left-hand drive to right-hand drive. So at 6 a.m., so they shut down at midnight, 6 a.m. the next day, traffic was able to assume. It was chaos. Chaos, as you would expect. But not one incident was recorded the next morning. They were expecting it to be terrible, right? So what they seen in Sweden actually was, as a result of that, their incidents went way down for about 18 months. And they started to creep back up over time. So we would suggest that if you want to have a huge impact on vehicle safety in Saskatchewan, we just do the same thing. Every 18 months, we just switch sides of the road. And I always say that, and I'm from Saskatchewan, so I can joke about this, but people from Australia and other places that they drive on the left side of the road, they say, yeah, we always drive on the left side of the road, and I always say we drive on what's left of the road. Risk homeostasis theory basically says that if people feel comfortable, they're going to take more risk. And if they feel at risk, they're going to take less risk, right? So this is Professor Wild. For you safety professionals in the room, I'd definitely go and have a read on that. They did a bit of a study. So this fella is in the crosswalk. He's well guarded. He's protected, right? He's following the requirements. This individual did a study at one of the universities. He got on his bike and pedaled for a whole day. In his backpack, in the bottom left, he had a sonar of sorts, and it was recording how close vehicles were getting to him. He didn't have any PPE on. He had capris, no helmet. When he dressed up, still the same sonar in his backpack, but he was fully equipped. He had a helmet. He had reflective striping. He had the right shoes on. Even had a face mask on. He found that the vehicles were 23% closer to him than when he wasn't prepared. If people feel that they're more comfortable and there's less risk, they will take more risk. Yogi Berra, the future just ain't what it used to be. Autonomous cars. Volvo promises death-proof cars by 2020. But there's a dilemma with these cars sometimes, right? So if you see this young fellow out there playing soccer, and if you're given the situation where if you turn left, you see this oncoming heavy truck. If you turn right, there's some sort of situation there. It's likely going to be a fatal impact. What do you do? As a driver, do you stay in the middle? Do you go left? Do you go right? It's a huge dilemma, right? Sometimes it comes back to our muscle memory. What do you think how that dilemma gets handled if you're in an autonomous car? If you're driving an autonomous car, you're given the same situation. What do you think that car is going to do? It's going to run the kid over. Why? Less risk. Are you ever going to buy a car that can't say that the protection of the driver and the family in that car is of the utmost importance to the purchaser of that car? Probably not. Einstein also said, I fear that the day that technology will surpass our human interaction, the world will have a generation of idiots. All right, Pulpit Rock, Norway. 604 meters in the air. Not one fatality. I just Googled this again last night. Every time I do one of these presentations, I check. Not one fatality. How can we ensure we have a fatality? Any ideas? It's the best way to kill somebody on Pulpit Rock. Put up a guardrail. Absolutely. You're going to have my kids over there taking selfies and leaning over the fence, not paying attention. Right. So we talked about this before, human behavior in hazardous situations. Your chance of success, if you're a human, comes back to the early days when we would have to survive just by finding food. Your chances of success go up with the amount of risk you take. If you never leave your cave, you never get any food, you're going to starve. If you go out and you take too much risk, you're also going to die. So if you don't take enough risk, you die. If you take too much risk, you die. Sometimes in safety, in organizations, we would suggest that maybe we have too much safety, too much protection in place. And the other side, maybe we're taking too much risk. So the balancing act there is to find where we have smart risk management. Sometimes when we have too much safety, we get paralyzed by our protection. So Target Zero has done awesome things for us as an industry. It's gotten us to where we are today. And we have the Heinrich triangle, or the bird triangle. There's two different interpretations, and the numbers are slightly different, but the same interpretation. But we focus on the top events with the idea that if we fix all these near misses, like on the Titanic, if there was 600 deck chair incidents that we dealt with, we would have prevented hitting the iceberg. So not all near misses are related to a fatal risk. Some of them may be. So the math trap, 0 fatalities, 0 serious injuries. It's our moral obligation to set these as our missions. And it's served us well, and it's going to continue to serve us well. The unintended consequences sometimes, though, in some organizations we've found, is that below the water, you get minor injuries. They also set targets for 0 minor injuries. To get 0 minor injuries, you have to have 0 incidents, 0 near misses, 0 error, then 0 risk. To have 0 risk, you have to have 0 hazard, which means 0 productivity typically, right? So does 0 equal safe? Here's an interesting intersection. We probably went through a similar intersection on the way to this conference today, the Institute today. And watch that car go through the intersection. Not even a scratch. So statistically, that's a safe intersection. There wasn't one stat came out of that. Safe intersection. So does the absence of stats mean that we're safe? Potentially, but I'd like to challenge that. Trap of targets. Einstein's also said, not everything that can be counted counts, and not everything that counts can be counted. There are some things in safety that are not quite tangible. It's hard to put a number to them. It wasn't actually Einstein, we found out later. It's a sociologist by the name of William Cameron, but we like to put Einstein on there because if we put William Cameron up, nobody would know who that was. All right, and we reward achievements. The deception of pretension. Deception of pretension basically means this is where we pretend that we're safe as we're communicating information up to our leaders, and they pretend to believe us. So you'll see things like this, 3 million person hours without work, without a LTI, things like that, right? And this has served us well. Setting targets is absolutely critical. But we're suggesting maybe it's something we need to challenge as we're trying to break through the wall. So we send our people out to the workforce, they're well protected, they're suited up, they're good to go, and then we set targets for them. 0 injuries, 0 accidents, things get better, the injury rates come down, we punish at-risk behavior, we set requirements for 0 deviance, and then we hit this line where we cross into a state where the people in the workforce are getting apprehensive. We reward safe behaviors, and we continue to see improvement. We get 0 tolerance requirements, and now that brings anxiety. It goes from apprehensive to anxiety in the workforce. We reward 0, and here's where we see things typically split. And you have your TRIF and your FRIF. Your TRIF is your true recordable injury frequency, and the F is your fake recordable injury frequency. And it typically is the FRIF that we see all too often in our industry. And it's because of fear of reporting, right? Even if we don't intend it, it's an unintended consequence, but it can happen, and it does happen. And this breeds risk secrecy. Risk secrecy is this great little filter. It kind of sits in the middle between good news and distorted news getting to leadership. And it doesn't let anything else through, especially the bad news. The bad news sits down at the bottom, can't break its way through to get up to leadership. This comes back to my Grant Davis story. Told you I'd come back to it. Some of you were shocked. A few of you were maybe a little bit irritated with me with the story, right? But what did you see? When that elephant reached down and picked up Grant, you seen him being put on his back and they were going to go off into the sunset. You seen the credits rolling already. Love story, right? We wanted the good news story. As humans, we want the good news stories. So the fact that leaders get this sort of information isn't because they're bad leaders. It's just the way that organizations are constructed, right? We have to be able to break down those barriers and get the right information to flow up. So Risk Secrecy, the manager of the Piper Alpha, he says, I thought that everything was okay because I never got a report that anything was wrong.
The tension in every drilling operation is between doing things safely and doing them fast. Time is money, and this job was costing BP $1 million a day. The day of the accident, BP flew several managers to the Deepwater Horizon for a ceremony to congratulate the crew for 7 years without an injury. For 7 years without an injury.
So we looped that because does anybody here believe that they went for 7 years without an injury? It's a high-risk organization. I highly doubt it, right? And they still got paid. Their executives got paid that year based on their stats. They got their bonus. They were rewarded, right? Transocean execs get bonuses despite that year. So this is that pretension. We pretend to believe them. What gets measured gets done, and in management that is an awesome principle. However, I'd submit that in safety, what gets measured gets manipulated. The delusion of invincibility as a result. So, we showed you this a little earlier. We've hit this wall. We've got all these things that have gotten us here. They've served us well, and they will continue to serve us really, really well in the future. How do we bust through that wall? At SafeMap, we believe that we have to start changing some of these myths, some of these delusions. We have to move to focus on complex exposure, dynamic random systems. Humans have to be the strongest link. We have to have a deference to autonomy. Create invisible safety, readiness to respond to risk, and resilience through leadership. Thank you.